Hello, my name's Daniel Bunt. I'm a student at the University of Newcastle. I'm studying a Bachelor of Teaching, Secondary, and a Bachelor of Science with the aim of becoming a high school science teacher. This presentation is part of my assessment for my course SCIT2100, and this presentation will be a demonstration of a science experiment conducted in classrooms the world over, I'm sure. Basically, the question I'm asking is, how does dishwashing liquid work? Now let me explain it for you. Right here we have a dishwashing liquid molecule. A dishwashing liquid molecule is bipolar. Bipolar because it has polar characteristics and non-polar characteristics. This small head of the molecule is polar, therefore that means it's attracted to water. The rest of it is non-polar, meaning it hates water, it repels water, it does anything it can to get away from the water. So when we throw a dishwashing liquid into the sink with our dirty dishes, all these little polar ends, they go racing around the sink, trying to attach to other water molecules and each other. And in the process, they break down the fats and greases we have in our dirty dishwater. And by the end of it, what we get, we have all these polar heads. They're the little polar heads of the dishwashing liquid. The non-polar tails, what they'll do, they'll trap. In here, that's a little grease molecule or fat. Once this little grease molecule or fat molecule, once that's surrounded by all these polar heads, therefore it's soluble in water, making it easier to wash our dishes. Now we don't see this happen when we do it in a sink because water's clear. We don't see what actually happens. We don't see these dishwashing liquid molecules race around and chase all the grease molecules to trap them and make it doing our dishes easier because, as I said, the water's clear. But this experiment, we'll be able to observe. We can observe what actually happens. It's a simple experiment. You can do it at home. It's great for young kids because it's quite visually stimulating, but it's good for older kids as well. It's good for high school kids because it does link in with the stage 4 syllabus, and we can actually explain the chemistry behind it, which I just did there. We need milk. Why do we use milk? Milk is similar to dirty dishwater. It's mainly water, but it contains a lot of other particles which are milk solids, which are fat, which is what these things are going to attract. Obviously dish soap, some food colouring and some cotton tips. Full cream milk is the best. Why full cream milk? More milk, more fat. It's going to work better. Right, let's see how we go. I'll just move this camera down. I've got it set up here. I've got some milk in some bowls. I've put some food colouring in there. It's been sitting in there for about 10 minutes, so it's all dispersed nice and evenly. I've got a cotton tip. I'll dip the cotton tip into some of the dishwashing liquid and we'll see what happens. We're going to watch these dishwashing liquid molecules race around this milk, encapsulating and enveloping all the little fat molecules that are in the milk. Ready? Here we go. Still a little bit of reaction there. Try another one. It's still going, that first one. Here they go, racing around. Whoa. So as you can see, it's quite easy to see why the kids love it, the young kids love it. A couple more here. Whoa. Let's try heating that one. And the last one. So as you can see, as soon as it hits the water, you can see some of them are still reacting. Oh, that was a good one. You can see the molecules, the dishwashing liquid molecules just chasing around, chasing all them fat molecules, linking together with all the water molecules and the other hydrophilic dishwashing liquid molecules. There you go, quite effective. Well, thanks for watching. I hope you found it informative and interesting. And thanks again. Cheers.